Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, in today's question, we are given an integer n and we can do the following operation any number of times we want. So if n is even, we can either do n by 2 or change n to n XOR 3 plus 1. And if n is odd, then we can only change n to n XOR 3 plus 1, where this symbol represents the XOR bitwise XOR operation. Now we need to check if it is possible to go from n to 1 in any number of operations. If it is possible, we need to print yes, otherwise no. Now in the test cases, we are given that the number of test cases will lie in between 1 and 10 raised to the power 4 and n will lie in between 1 and 10 raised to the power 15. So we need to come up with some really efficient method to check this up, right? Now let's see the sample inputs once to make it much more clear. So in the first input, we're given n equal to 1, so it is already 1, so the answer is yes. In the second, we're given n equal to 2 and we can do 2 by 2 and we'll get 1. So the answer is yes. In the third, we're given n equal to 3 and if we do the operation of XORing it with 3, we'll get 0, 0 and if we add 1, we'll get a 1 only. So we got a 1 by 1 operation. So for n equal to 3, the answer is yes. For n equal to 4, we can do 4 by 2 and we'll get a 2 and then we can again do 2 by 2 and we'll get a 1. Hence the answer is 1. For n equal to 5, it is not possible. For n equal to 6, we can first of all do 6 by 2 and we'll get a 3. And then we can apply the operation that we did on 3 and we'll get a 1. So the answer is yes. For 7, it is not possible. So the answer is no. For 8, we can do 8 by 2, then again 8 by 2, and then again 8 by 2. So we'll get a 4, then a 2, and then we can again do 2 by 2. Sorry, 4 by 2, then we can do 2 by 2, and then we'll get a 1 finally. So the possible answer is yes. For 9 and 10, it is not possible. So the answer is no. Now let us move to the solution. So we are given these two operations, which are we can either, if n is even, we can either do n by 2 or n XOR 3 plus 1. And if n is odd, we can only do n XOR 3 plus 1. Now this operation n XOR 3 plus 1, that is equivalent to writing this 3 in binary form, right? And for this much part, the only bits which will matter are going to be the most least significant bits, right? The two most least significant bits, right? The two LSBs are the only things which are going to matter. So let's just try to simulate this operation on all the four possible cases of the LSB. If our last significant bits are like 0, 0, 0, 1, 1, 0 or 1, 1. And let's try to see what happens if we apply this operation on those numbers, right? So if n is odd, then the last two bits would be either 0, 1 or 1, 1, right? And let's say the previous bits could be anything. Now if we do this XOR 3, we're going to get 1, 0, right? These two are going to change, so we'll get a 1, 0. And if we do a plus 1 in it, we'll get a 1, 1, right? And rest everything is going to remain exactly the same, right? So if this was our n, then what is this? It is simply n plus 2, right? Because this bit got changed from 0 to 1, which is equivalent to adding 2 in this, right? And this representation is exactly similar to this representation, all right? Now what happens if we do the operation on this representation? If we do a XOR with 1, 1, we'll be getting this 0, 0. And if we add a 1, we'll get 0, 1 over here, right? So if this was our n, then what is this? This is n minus 2, right? Because this was 1 and this became 0 and rest everything is same. So this is equivalent to subtracting 2 in our operation, right? And this is exactly same as this, right? So what will happen if we do this operation multiple times? If we have this initially, it will become this. And by applying the operation again, it will become this, right? So these are basically interchanging with each other and the cycle will continue. So either if the number is this, it will become n plus 2, or if the number is this, it will become n minus 2, right? And nothing else is possible to get out of this. So under what circumstances can we get n equal to 1 by applying some operations? So if n is already 1, then obviously we have got it right. Or if n is equal to 3, we can apply the operation and we'll get n minus 2. and we'll simply get 1, right? Now, if n is any other odd number, let's say n is 7, what will happen if we apply the operation? And it is 1, 1, 1. If we apply the operation once, it becomes the XOR will become 1, 0, 0, and then it will become 1, 0, 1. So it will become 5, right? Now, what happens if we apply the operation again? It will become 1, 1, 0, and if we add 1, it will become 1, 1, 1 again. So it will become 7, and the cycle will repeat and will not get anything else, right? So if n is odd, then the only possible way to get our answer is going to be either choose n equal to 1 or choose n equal to 3. And for all the other odd values of n, the answer would be no, right? Now let's see the case for the even. So let's first consider this case. So we have these two as zeros. Now we do a XOR with 1, 1. What will happen? Both of them will become 1, and then we'll add 1. So what will happen? 1 plus 1 will be 0. 1 would be a carry over here. Then 1 plus 1 will be 0 again, and there would be a carry of 1. And in this number 100 would be added, right? Which is equivalent to adding 4 in this number, right? So if this was our number, we'll be adding n plus 4 in it, right? So if our number was n, after applying the n XOR 3 plus 1 operation, it will become n plus 4. Also notice here that this number is already a multiple of 4. Why? Because these last two bits are zeros. And because these last two bits are zeros, this number will always be a multiple of 4. So we are adding a 4 in a multiple of 4. So this number will also be a multiple of 4. Right? And we can just keep applying this operation until we get some multiple of 4, which is a power of 2. Right? We can always get this, right? Like we can just keep applying the operation until we get a power of 2. And as soon as we got a power of 2, we can just keep dividing it by 2. So if let's say we got some number x, which is a power of 2, then we can just do x by 2, then x by 2, then x by 4, then x by 8. And ultimately we'll just always get a 1, right? So it is always possible to get to reach 1, right? So if n is a multiple of 4 and modulo 4 is 0, then the answer is always yes, right? Now let's consider this case. Now in this case, we have 1, 0 over here. We do the XOR operation with 1, 1. We got a 0, 1. And then we added 1 in it. And we got 1, 0 again. And the numbers are exactly the same, right? So it was n and it remains n. So only the n by 2 operation will matter here, right? Because doing 3's or n plus 1 will give us n only, right? Now what will happen if we do this n by 2 operation once? This was an even number. It will become odd, right? Because what happens when we divide by 2? It right shifts by 1, the overall number right shifts by 1. And if we just divide it by 2, the overall number, if we divide by 2, the overall number right shifts by 2. And if we multiply by 2, the overall number left shifts by 2, left shifts by 1, right? So what will happen if we just do n by 2? The number, this 0 will get removed and the number will become this, whatever it was up till here, and then a 1. Right, now if this thing is a 0, then the only possible way we could get an answer was 1, right, as we discussed here. Like if the number is of this form, then the only possible way in which we can get a possible answer would be 1, right? And if this x is a 1, then the only possible way in which we can get an answer is this n by 2 equal to 3. Right, so if n by 2 is 1 or 3, then what would be the values of n when this is possible? So n would be equal to either 2 or n would be equal to 3 times 2, which is 6. Right, so these are the only possible cases when we'll have our answer is yes. So just to summarize, the answer would be yes if and only if n is a multiple of 4 or n is equal to any of the 1, 2, 3 and 6. Right, otherwise the answer is no. Right, and that's pretty much the whole solution. And we can easily compute this in constant time and just print the answer for each test case. So the time complexity of the overall solution would be constant. So now let's see the code in C++ and Python. So this is the code in C++. Notice here to take in the input using long because the input of n could be as big as 10 to the power 15. Now we just need to simply check if n modulo 4 is 0 or if n is 1, 2, 3 or 6 will print yes. Otherwise we'll be printing no. And that's pretty much the whole solution. Now let's see the solution in Python. So we'll just run a loop for each test case. We'll take an input of n. Now we'll simply check if n is 4 or n is equal to 1, 2, 3 or 6. If it is, we'll print yes. Otherwise we'll print no. And yeah, that's pretty much the whole solution. I hope you liked it. Thanks. Bye bye.